Now I'd like to discuss rotations. So previously we talked about various different transformations, okay? If you remember, we talked about scaling, okay, when we were looking at the equilateral triangle. Then we looked at reflections, okay? We looked at reflections in detail using a point in the 2D plane. Now I'd like to focus on rotations, okay? So again, using a point in the 2D plane. Okay, if we choose the point 4, 1, just as an example, we could have chosen any point that we liked. Let's take the point 4, 1. Now, I've joined the point to the origin here with a red line, okay? This is just to make the rotation more obvious, okay? So what I'm going to do is, we could of course rotate this point any angle we like, okay, and we'll explore that in the next video. But for now, I just want to take 90-degree rotations, okay? So, what we have is, the point is 4, 1, and we're going to do as the first rotation a rotation of 90 degrees. So the axis of rotation is the origin here. If you imagine putting your finger here and holding it, the point would rotate around the center, or around the origin. Okay, so that would be a rotation of 90 degrees. Okay, of course we also, like every other situation, we have the identity rotation. So the identity rotation is the do nothing rotation, so you just leave the point 4, 1. So that would look like this. 4, 1 would go to 4, 1. Okay. If we do the rotation of 90 degrees, you might be able to see the point moves from the point 4, 1 over to the point minus 1, 4. It's minus 1 backwards along the x-axis and 4 up the y-axis. Okay, so you can see that 4, 1 goes to the x and y swap, and the x becomes negative, so it's minus 1, 4. Okay? If we still stay at this point 4, 1, but now we do a 180 degree rotation, so R 180, okay? The point moves from 4, 1 over here. So where is that? That's minus 4, minus 1. Minus 4, minus 1. Okay, it's underneath the y-axis and it's into the negative x. So that means that the 4, 1 point gets transformed to minus 4, minus 1. Okay? Then, if we start again at 4, 1 and we do a 270 degree rotation, we come back to this point here. So R270 means 4, 1 gets transformed to, where does it go? It's at the position 1 along the x and minus 4. 1 minus 4. Okay? So, this was specifically to do with the point 4, 1, but I'm going to generalize this, make it more abstract, so we can use these results later on. So, we can say, effectively, that the identity element sends the point AB to the point AB. The rotation of 90 degrees, rotation of 90, sends AB, the point, to minus B, A. Okay? Rotation of 180 sends AB to the point minus A, minus B. Okay, minus A, minus B. Then R270 sends the point AB to B minus A. Okay, now obviously we could do rotation of 360, but that would bring us back to the beginning, and it's the same as the identity element. Okay, so these are our rotation transformations for a point in 2 dimensions. Okay, you might be able to see that there's an interesting case here, right? This point over here, if you take the point 4, 1 and rotate 180 degrees, you come to -4, -1. But this same transformation of rotation 180 brings AB to -A minus B. That's equivalent to a reflection in the origin. Okay? So, a reflection in the origin is the same as a rotation of 180 degrees. And you can see that. Okay, you can rotate twice around here, or you can reflect through the origin. Okay, so there's some interesting cases to be aware of.